A few words about the digital sensor age. We all are right in the middle of it, and tried to show that by a picture because usually it is better than words. We are surrounded by sensors really everywhere, and most of us don't even realize that they are there. I mean, did you know that your vacuum cleaner has a MEMS sensor in there these days, or your coffee machine? So sensors are really everywhere, and the number is growing. Here on the right-hand side, you see the most obvious applications for digital sensors. Mobile devices are packed with it. We see more and more robotic solutions that wouldn't be possible with digital sensors, but also simple household devices, gaming devices, and of course, medical systems are equipped with digital sensors. So it's totally appropriate to talk about the digital sensor age. We are right in the middle of it. I give an example here. We all carry smartphones these days. And just to give you an introduction, or just to show you the evolution of that. That's a relatively old device now already, but already the iPhone 5 contained 7 digital MEMS sensors. Of course, the most obvious ones, cameras, but there are so many light sensors in there and the inertial sensors as well. And over the development stages of just that one single smartphone generations, you see that the number of sensors in total has constantly increased. And to cope with all that, of course, you need to have a test system that is capable of testing all these devices. Another example that is absolutely obvious in terms of sensors and smart devices is, of course, autonomous driving. You see here just a highlight picture on what components of a car you might see sensors, and I'm pretty sure that one is not even covering what we really see in the market when fully autonomous cars are rolled out. To give you a picture about the autonomous driving levels, we think, and the industry is quite hesitant to give clear numbers, but just the autonomous level 3, what the ADAS level 3 represents, will increase the number of sensors per car significantly. So a lot of sensors are around us. Digital. What is a digital sensor? So in the end, a sensor is of course measuring its environment, but the representation of that data is by a digital sensor protocol. I named a few here. Some of you might be aware about these abbreviations. But these are typical digital sensor protocols, and so the sensor is transporting data by these standards. And there's a huge variety of it. You see, I made 3 dots here on purpose. There are so many that are new that might be just for specific applications. So digital sensors are really everywhere. An example of why, even though we call all of these sensors digital is not equal digital. I just picked an example here. I picked 3 standard consumer MEMS accelerometers here from STMicro, Bosch, and Analog Devices, and just want to show you how different these devices represent their data. Not only that the power supply varies, they have different resolution of their measurement values, and that, having said that, they also are able to transport that digital data with totally different transfer speeds. And once you have the electrical and logical interface ready, then you need to know where in the memory of the device your measurement value is stored. So you see, every device has a totally different way of representing the data, even though all of these data is represented digital. And that is important for someone who has to work with and test MEMS digital sensors, because the variety is huge. I give another quick view on how data is then interpreted once it actually is delivered by the sensor. So here you see a typical consumer accelerometer with a quite wide range of quite a sensitivity range. But the SPI data output that is captured has, of course, a decimal representation. And that correlates to the measured acceleration of that sensor on that specific axis. So you see, it's not only getting the sensor connected with the right electrical interface, with the right protocol bus, but also be able to properly interpret every sensor's output in the right way. To use it in an application is quite challenging due to the variety that is possible. So then there's another aspect that comes into the game when we talk about digital MEMS sensors. The complexity of systems has increased because MEMS sensors are simple in a way, easy to handle, they are cheap, but this introduces quite some market dilemma for companies that manufacture and for companies that want to verify the sensor's operation. The average selling price of sensors has to go down. Remember what I said earlier about the number of sensors that are equipped in an autonomous car? It requires, the industry simply requires vendors to go very low in average selling price. And that actually contradicts the requirements that are caused by the complexity that is constantly growing as more and more functions go into these sensors. And to cope with that, you need to have a flexible test system because you have a cheap device and you don't want to add significant extra test cost, even though testing a sensor is quite complex. So that is a dilemma.